There is a possibility that the circuit in question is a 240-volt circuit, but the original thermostat wasn't a line voltage thermostat. Instead, it might have been a low-voltage thermostat utilizing a transformer to reduce the voltage to 24 volts. Given this, the wiring configuration within the thermostat box becomes clearer. The two black wires would function as the incoming and outgoing hot wires carrying 240 volts. The two white wires would serve as the neutral wires connected together. One black wire would connect to the line terminal of the thermostat, providing power to the transformer, while the other black wire would connect to the load terminal of the thermostat, supplying power to the heaters. To evaluate this hypothesis, firstly, disconnect the original thermostat. Secondly, measure the voltage between the two black wires. If the reading is 240 volts, this confirms it's a 240 volt circuit employing a low voltage thermostat. If the voltage does not measure 240 volts, the circuit might be 120 volts, and the original thermostat was potentially wired incorrectly. Other possibilities to consider if the aforementioned steps do not resolve the issue include the circuit breaker potentially being disabled, possibly a 15 amp single pole circuit breaker. It's also conceivable that an open neutral exists somewhere within the circuit, resulting in anomalous voltage readings. Additionally, the newly installed thermostat may be faulty. Seeking assistance from a qualified electrician is highly recommended for diagnosing and resolving the problem, especially if you lack extensive experience with line voltage circuits. Utilizing a multimeter to measure voltage at various points within the circuit is crucial to validate the voltage and wiring configuration. Examining the nameplate on the baseboard heaters can also determine their voltage rating. Electric baseboard heaters operate through resistance, converting electrical energy into heat. The amount of heat generated is directly proportional to the current flowing through the resistance element and the voltage applied. To determine the correct thermostat type and wiring, it is crucial to understand the system's voltage, whether it's 120 volts or 240 volts. Line voltage thermostats directly control the power to the heating element. Low voltage thermostats, on the other hand, use a transformer to step down the voltage and control a relay, which in turn controls the power to the heating element. This method allows for more precise temperature control and often facilitates features like programmable settings. When dealing with electrical work, safety is paramount. Always turn off the power at the circuit breaker before working on any electrical components. Verify the circuit is de-energized using a non-contact voltage tester or a multimeter. Wear appropriate personal protective equipment, including insulated gloves and eye protection. If you are uncomfortable or unfamiliar with electrical work, it's best to consult a qualified electrician. Troubleshooting electrical problems requires a systematic approach. Firstly, gather information about the system. Determine the voltage of the baseboard heaters, the type of thermostat being used, and the wiring configuration. Secondly, visually inspect the wiring for any obvious problems such as loose connections, damaged wires, or signs of overheating. Thirdly, use a multimeter to measure voltage and current at various points in the circuit. This will help to identify any problems such as open circuits, short circuits, or voltage drops. If the voltage between the black wires is 240 volts and the thermostat is designed for 120 volts, it could explain why the system isn't working correctly. The thermostat may be damaged or not functioning properly due to the higher voltage. In this case, the thermostat needs to be replaced with one that is rated for 240 volts. If the voltage is 120 volts, but the baseboard heaters are designed for 240 volts, the heaters will not produce enough heat. In this case, the heaters need to be replaced with ones that are rated for 120 volts, or the circuit needs to be rewired for 240 volts. Open neutrals can be tricky to diagnose because they can cause voltage to appear on the circuits that are supposed to be dead. This can be dangerous because it can create a shock hazard. To test for an open neutral, measure the voltage between the neutral wire and ground. If the voltage is anything other than 0 volts, there is an open neutral somewhere in the circuit. An improperly labeled circuit breaker can also cause problems. If the breaker is labeled incorrectly, it could be providing the wrong voltage to the circuit. To test this, use a multimeter to measure the voltage at the circuit breaker. Make sure the voltage matches the label on the breaker. If the voltage is incorrect, the breaker needs to be replaced with one that is properly labeled. When installing a new thermostat, carefully follow the manufacturer's instructions. Make sure the thermostat is compatible with the voltage of the circuit and the type of heating system. Connect the wires to the correct terminals and tighten the screws securely. Double-check all connections before turning the power back on. If the baseboard heaters are not working after the new thermostat has been installed, check the circuit breaker to make sure it is not tripped. If the breaker has tripped, reset it. If the breaker trips again immediately, there is a short circuit in the system. In this case, call a qualified electrician to diagnose and repair the problem. Electric baseboard heaters come in various wattages and lengths. The wattage of the heater determines the amount of heat it will produce. The length of the heater determines how much space it will cover. When choosing baseboard heaters, it is important to select ones that are the appropriate wattage and length for the room they will be heating. It is also important to consider the insulation of the room. A poorly insulated room will require more heat to maintain a comfortable temperature. The National Electrical Code, or NEC, provides guidelines for the safe installation of electrical wiring and equipment. When working on electrical systems, it is important to follow the NEC guidelines to ensure safety and prevent fires. Some relevant NEC articles include Article 210.23. A, which discusses permissible loads for branch circuits, Article 240.4. D, which covers protection of flexible cords and fixture wires, and Article 424.3. A, which speaks about branch circuits for fixed electric space heating equipment. The NEC provides detailed requirements for circuit sizing, overcurrent protection, and wiring methods. It also addresses specific requirements for electric heating systems, including baseboard heaters and thermostats. Always consult the latest edition of the NEC for the most up-to-date information. Electric heating systems can be complex and potentially dangerous. If you are not comfortable working on electrical systems, it is always best to call a qualified electrician. A licensed electrician has the knowledge, skills, and experience to diagnose and repair electrical problems safely and effectively. They can also ensure that the electrical system is installed in accordance with the NEC guidelines. When selecting an electrician, it is important to choose one who is licensed and insured. Ask for references and check online reviews. Get a written estimate before work begins. Remember that electricity can be dangerous, and it is always better to be safe than sorry. When testing for voltage, it's crucial to use a properly functioning multimeter. Ensure the multimeter is set to the correct voltage range, alternating current or direct current, as appropriate for the circuit being tested. When testing for voltage, place the multimeter probes on the points where you want to measure the voltage difference. For example, to measure the voltage between two black wires, place one probe on each wire. To measure the voltage between a wire and ground, place one probe on the wire and the other probe on a grounded metal surface. Exercise caution to avoid touching any exposed metal parts of the circuit while testing. Wear insulated gloves and use a multimeter with insulated probes. If you are unsure how to use a multimeter safely, consult the manufacturer's instructions or seek guidance from a qualified electrician. When working with electrical wiring, it is important to use the correct size and type of wire for the application. The size of the wire is determined by the amount of current that will carry. The type of wire is determined by the environment in which it will be installed. The NEC provides tables that specify the appropriate wire size for various current ratings and applications. Some common types of wire used in residential wiring include non-metallic sheath cable, NM, and armored cable, AC. NM cable is typically used for interior wiring in dry locations. AC cable is typically used for interior wiring in dry or damp locations. When installing electrical wiring, follow the NEC guidelines for proper installation methods. These guidelines cover topics such as wire bending radius, support spacing, and protection from physical damage. It is also important to use the correct type of connectors and fittings for the wiring being used. Electric baseboard heaters are typically controlled by either line voltage thermostats or low voltage thermostats. Line voltage thermostats directly control the flow of electricity to the heating element. They are typically used in older homes and are relatively simple to install. Low voltage thermostats use a transformer to step down the voltage to a lower level, typically 24 volts. This allows for more precise temperature control and can be used to control multiple heaters from a single thermostat. Low voltage thermostats are typically used in newer homes and are more complex to install than line voltage thermostats. When replacing a thermostat, it is important to choose a thermostat that is compatible with the type of heating system being used. If you are replacing a line voltage thermostat, you must replace it with another line voltage thermostat. If you are replacing a low voltage thermostat, you must replace it with another low voltage thermostat. It is also important to choose a thermostat that is compatible with the voltage of the circuit. If the circuit is 120 volts, you must choose a thermostat that is rated for 120 volts. If the circuit is 240 volts, you must choose a thermostat that is rated for 240 volts. When wiring a thermostat, carefully follow the manufacturer's instructions. Make sure to connect the wires to the correct terminals. If you are unsure how to wire a thermostat, consult a qualified electrician. Electric baseboard heaters can be a convenient and efficient way to heat a home. However, it is important to install and maintain them properly to ensure safety and prevent fires. Always follow the NEC guidelines when working with electrical wiring and equipment. If you are not comfortable working on electrical systems, consult a qualified electrician. Always remember safety first when working with electricity. Always turn off the power at the circuit breaker before working on any electrical components. Verify the circuit is de-energized using a non-contact voltage tester or a multimeter. Wear appropriate personal protective equipment, including insulated gloves and eye protection. If you are unsure how to perform a task safely, consult a qualified electrician. Understanding the voltage and wiring configuration is crucial for diagnosing and resolving the issue. Consider the possibility of a mislabeled circuit breaker, an open neutral, or a damaged thermostat. Test the voltage at various points in the circuit to confirm the voltage and wiring configuration. Refer to the nameplate on the baseboard heaters to determine their voltage rating. This step-by-step approach, combined with a thorough understanding of electrical principles, will help you to effectively troubleshoot and resolve the thermostat and baseboard heater problem. Remember to prioritize safety and consult with a qualified electrician if you are unsure about any aspect of the work. Consider the use of a clamp meter to measure the current flowing through the wires without disconnecting them. This can help identify overloaded circuits or faulty components. Always use insulated tools when working with electrical wiring. Double-check all connections to ensure they are tight and secure. After completing the work, test the system to ensure it is functioning properly. When dealing with older wiring, be extra cautious as the insulation may be brittle and prone to damage. Consider replacing old or damaged wiring to improve safety and reliability. Keep a record of all work performed, including wiring diagrams and test results. This will be helpful for future troubleshooting and maintenance. Educate yourself on basic electrical principles and safety practices. This will enable you to perform minor electrical repairs safely and effectively. Always consult a qualified electrician for any major electrical work. By following these guidelines, you can safely and effectively troubleshoot and repair electrical problems in your home. Understanding the fundamental principles of electricity is essential for anyone working with electrical systems. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amperes. Resistance is the opposition to the flow of electrical current. It is measured in ohms. Ohm's law states that the voltage across a resistor is equal to the current flowing through the resistor multiplied by the resistance. This can be expressed as volts equals amps times ohms. Power is the rate at which electrical energy is transferred. It is measured in watts. Power is equal to the voltage multiplied by the current. This can be expressed as watts equals volts times amps. Understanding these basic electrical principles is essential for troubleshooting electrical problems and ensuring the safety of electrical systems.